integration of 10x raised to 9 plus 10 raised to x log 10 upon x raised to 10 plus 10 raised to x. Integration of f dash x upon fx is simply log mod fx plus c. Here, as you can see, if we consider denominator as fx, then its differentiation is available in numerator. So directly you can say the answer is log mod your denominator, which is x raised to 10 plus 10 raised to x plus c, which is given in option D. Ta-da! Similarly, we have another shortcut, or we can say formula, that fx whole raised to n into f dash x dx will be equal to fx whole raised to n plus 1 upon n plus 1 plus c, where n is not equal to minus 1. If n is equal to minus 1, then we have to use the first formula. Okay, so use this formula wisely. Now let's move to the next question. In this question, we have to integrate under root of 10x upon sin x cos x. As you can see, 10x is the inner function. So by force, we have to assume 10x is equal to t. Now, if we differentiate both the side, we will get sec square x dot dx is equal to dt. But we don't have sec square x within the multiplication of dx. So first of all, we have to adjust the question. So under root of 10x will be as it is. To get sec square x, we should get cos square x. We already have 1 power of cos x. So just multiply and divide by cos x. So here we can say under root of 10x will be as it is. In denominator, this sin x upon cos x will become 10x, and this cos x into cos x will become cos square x, or we can say sec square x dot dx. So here we get under root of 10x, or we can say 10x raised to 1 by 2 upon 10x raised to 1, which will give us 10x raised to 1 by 2 minus 1, or we can say minus 1 by 2 into sec square x dot dx. So we are ready to modify our integration. Instead of 10x, we have to substitute t raised to minus 1 by 2, and instead of sec square x dx, we will get dt. To integrate t raised to minus 1 by 2, we are going to use first formula, which will give us t raised to minus 1 by 2 plus 1, or we can say 1 by 2 by 1 by 2 plus c. So let's simplify. This 1 by 2 will become 2, and substitute the value of t, which is 10x raised to 1 by 2 plus c. Here's your final answer. Ta-da! So here we have to integrate x into under root of x plus 2, which is in the form of pmx upon ax plus b raised to n. So let's assume x plus 2 is equal to t. Differentiate both the side, we will get dx is equal to dt, and we can get the value of x as a t minus 2. We are ready to modify our integration. Instead of x, we have to write down t minus 2 under root of, instead of x plus 2, we can write down t, and instead of dx, we have to write dt. This root t can be rewritten as t raised to 1 by 2. Before we go for integration, let's simplify. T raised to 1 by 2 into t will give us t raised to 3 by 2 minus t raised to 1 by 2 into 2 will give us 2t raised to 1 by 2 dot dt. Now we are ready for integration. Integration of t raised to 3 by 2 will be t raised to 5 by 2 upon 5 by 2 minus 2 will be as it is. Integration of t raised to 1 by 2 will be t raised to 3 by 2 upon 3 by 2 plus c. Let's simplify. We will get 2 by 5. Instead of t, we have to substitute x plus 2 whole raised to 5 by 2 minus, here we'll get 4 by 3 x plus 2 whole raised to 3 by 2 plus c as your final answer. Ta-da! Here we have to integrate x upon under root of x plus 4. Here x plus 4 is your inner function. So let's assume x plus 4 is equal to t. So we can say your dx will be dt. So we are ready to modify our integration. Instead of x, we can get t minus 4. So let's write down t minus 4 in numerator upon under root of, instead of x plus 4, we have to write down t. And dx will be replaced by dt. For simplification, let's write down t raised to 1 by 2. For further simplification, let's give individual denominator. T raised to 1 upon t raised to 1 by 2 will be t raised to 1 by 2 minus 4 upon t raised to 1 by 2, or we can say t raised to minus 1 by 2 dot dt. Now we are ready to integrate it. Integration of 1 by 2 will be t raised to 3 by 2 upon 3 by 2 minus 4 will be as it is. Integration of t raised to minus 1 by 2 will be t raised to 1 by 2 upon 1 by 2. So 2 by 3, the value of t is simply x plus 4 raised to 3 by 2 minus 8 and x plus 4 whole raised to 1 by 2 plus c is your final answer. Ta-da! Here we have to integrate 3x plus 2 upon 3 minus 2x, and 3 minus 2x is the inner function. So let's assume 3 minus 2x is equal to t. Differentiate both the side. Differentiation of 3 will be 0 minus 2 into dx will be your dt. So we can say your dx is simply minus 1 by 2 dot dt. So we are ready to modify our integration. And for that, we are going to need the value of x, which will be 3 minus t upon 2. So in numerator, we will get 3 into, instead of x, we have to put 3 minus t upon 2 plus 2 upon 3 minus 2x will become t. And instead of dx, we have to write down minus 1 by 2 dot dt. But we don't have to worry about this minus 1 by 2. Let's simplify our numerator. We have to multiply 3 with 3. So we'll get 9 minus 3 into t will give us 3t. And here we have to take the LCM of 2. So 2 will multiply with 2 will give us plus 4 upon 2. And your t still remain as it is. So here minus 1 by this 2 can be multiplied with 2 and will give us 4. Integration of 9 plus 4 will give us 13 minus 3t. For further simplification, let's give individual denominator. So here we'll get integration of 13 by t minus dt will cancel out 3 dot dt. So we are ready to integrate minus 1 by 4 as it is. 13 is constant, we don't have to worry about it. Integration of 1 upon t is simply log mod t minus integration of 3, which is purely constant term, is simply dt plus c. Now, to get the final answer, just substitute the value of t. So 13 log mod, instead of t, we have to write down 3 minus 2x minus 3 will be as it is. 3 minus 2x plus c is your final answer. Ta-da! Here we have to integrate under root of ax plus b. Here ax plus b is an inner function. So let's assume ax plus b is equal to t. Differentiate both the side, we will get a plus b dot dx is equal to dt. So here we can say your dx is simply 1 upon a dot dt. Now we are ready to modify our integration. Instead of under root of ax plus b, we have to write down under root of t. And this dx is equal to 1 upon a dot dt. So we don't have to worry about this 1 upon a. We just have to integrate root t, or we can say t raised to 1 by 2 dot dt. So this 1 upon a is as it is. Integration of t raised to 1 by 2 is simply t raised to 3 by 2 upon 3 by 2 plus c, or we can say 2 upon 3a into the value of t is ax plus b whole raised to 3 by 2 plus c is your final answer. Ta-da! See, whenever you have this kind of a question in which we simply have function of ax plus b, then consider ax plus b as a one unit of a box. Then integrate under root of box, or we can say box raised to 1 by 2. Then its integration will be box raised to 3 by 2 upon 3 by 2. But we have ax plus b within the box. So we just have to divide the coefficient of x, which is a plus c. Ta-da! Which is similar to the previous answer. Here we have to integrate e raised to 2x plus 3, and 2x plus 3 is a first order polynomial. So let's consider box. So integration of e raised to box is simply e raised to box, and we have to divide the coefficient of x, which is 2 plus c is your final answer. Ta-da! Similarly, let's try to solve integration of x square 7 minus 4x. Here 7 minus 4x is first order polynomial. So integration of x square box is simply 10 box plus c. We just have to divide coefficient of x, which is minus 4. Similarly, let's try to solve integration of 10 square 2x minus 3. And to integrate 10 square, we have to convert into sec square. So it will be sec square angle, which is 2x minus 3 minus 1 dot dx. Integration of sec square 2x minus 3 is 10 2x minus 3 upon coefficient of x, which is 2, minus integration of 1 is simply x plus 3. Ta-da! Here we have to integrate 1 upon x minus under root of x, or we can say x raised to 1 by 2 and x raised to 1, which is in the form of 1 upon x raised to 1 by p plus 1 upon x raised to 1 by q, where q is greater than p. So first of all, we have to take x raised to 1 by 2 common. So in denominator, we will get x raised to 1 by 2, and x raised to 1 upon 1 by 2 will become x raised to 1 by 2 minus 1 dot dx. આ તમારું first step હતી. Now, in second step, we have to assume rest of the term, which is x raised to 1 by 2 minus 1. So let's assume x raised to 1 by 2 minus 1 is equal to t. If we differentiate both the side, we will get 1 by 2 x raised to 1 by 2 minus 1 will give us minus 1 by 2 dot dx. will be equal to dt, or we can say 1 upon x raised to 1 by 2 dot dx will become 2 dt. So here we can modify our integration as this 1 upon x raised to 1 by 2 dot dx will become 2 dt, and 1 upon x raised to 1 by 2 minus 1 is simply become 1 upon t. So we don't have to worry about this 2. We just have to integrate 1 upon t, which will be log mod t plus c. And to get the final answer, we just have to substitute the value of t, which is x raised to 1 by 2 minus 1 plus c. So 2 log mod x raised to 1 by 2 minus 1 plus c is your final answer. Ta-da! Here we have to integrate e raised to 2x minus e raised to minus 2x upon e raised to 2x plus e raised to minus 2x. Let's assume denominator as a t. So differentiation of e raised to 2x is simply e raised to 2x into 2 plus differentiation e raised to minus 2x will be e raised to minus 2x into minus 2 dot dx will be dt. So if we take 2 common, we will get e raised to 2x minus e raised to minus 2x dot dx is equal to 1 by 2 dot dt. So here e raised to 2x minus e raised to minus 2x dot dx will give us 1 by 2 dot dt, and 1 upon e raised to 2x plus e raised to minus 2x will give us 1 upon t. Now we don't have to worry about this 1 by 2. Integration of 1 upon t is simply log mod t plus c. So to get the final answer, just substitute the value of t, which is e raised to 2x plus e raised to minus 2x plus c. Ta-da! Here we have to integrate e raised to 2x minus 1 upon e raised to 2x plus 1. So let's divide numerator as well as denominator by e raised to x. So here we'll get e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Now we should assume e raised to x plus e raised to minus x is equal to t. So e raised to x plus e raised to minus x will be our new variable t. Differentiation of e raised to x will be e raised to x plus differentiation of e raised to minus x will be e raised to minus x into minus 1 dot dx is equal to dt, or we can say e raised to x minus e raised to minus x dot dx is simply dt. So we can easily modify our integration. E raised to x minus e raised to minus x dot dx will become dt 1 upon e raised to x plus e raised to minus x will become t. So integration of 1 upon t is simply log mod t plus c. And to get the final answer, just substitute the value of t, which is e raised to x plus e raised to minus x plus c. So log e raised to x plus e raised to minus x plus c is your final answer. Ta-da! In this question, you have to find integration of 2 cos x minus 3 sin x upon 6 cos x plus 4 sin x, which is in the form of a cos x plus or minus b sin x upon function of a sin x plus or minus b cos x. To set the differentiation of denominator in numerator, first of all, we have to take 2 common from the denominator. So we will get 3 cos x plus 2 sin x, and let's rearrange the terms of numerator. First of all, we will write down minus 3 sin x and then 2 cos x dot dx. Now let's assume 3 cos x plus 2 sin x is equal to t. So if we differentiate both the sides, we will get 3. Differentiation of cos x will be minus sin x plus 2. Differentiation of sin x will be cos x dot dx will be your dt. So we are ready to modify our integration. Minus 3 sin x plus 2 cos x dot dx will become your dt, and 1 upon this 3 cos x plus 2 sin x will become your t. So we just have to integrate 1 upon t, which is log mod t plus c. Just substitute the value of t, which is 3 cos x plus 2 sin x plus c is your final answer. Ta-da! Here we have to integrate 1 upon 1 minus 10x. So first of all, let's simplify this 10x in terms of sine and cos. So we can say here we have 1 upon 1 minus sine x upon cos x. So for simplification, let's take an LCM. This cos x will multiply with 1, will give us cos x minus sine x, and the denominator of the denominator will go in numerator. So here we get cos x dot dx. To get the differentiation of denominator, first of all, we need to multiply and divide by 2. So we can split this 2 cos x into cos x plus cos x, but we have cos x minus sin x in individual denominator. So we are going to need sin x in the numerator. So let's add and remove sin x, separate their integration. So here we'll get 2 integrations. Let's say your first term as a I1 and second term as a I2. So first of all, let's try to integrate our first integration. And to integrate this term, we have to assume cos x minus sin x as a t. So let's take cos x minus sin x as a new variable t. So if we differentiate both the side, differentiation of cos x will be minus sin x minus differentiation of sin x will be cos x dot dx will be your dt. Let's take minus cos x plus sin x dot dx will become minus dt. So here we are ready to modify our integration. This cos x plus sin x dot dx will become your minus dt, and 1 upon cos x minus sin x is simply t. We don't have to worry about this negative sign. Just integrate 1 upon t as a log mod t. And to get the final answer, we just have to substitute the value of t, which is cos x minus sin x plus c1. Now let's try to integrate our I2. As you can see, cos x minus sin x, cos x minus sin x will cancel out. We just have to integrate 1, which is x plus c2. So we can say our integration, which is half of I1 plus I2, is simply half of the integration of I1 over here plus your I2 plus C, where your C is C1 plus C2. Ta-da! Here we have to integrate 1 upon 1 minus cot x, or we can say we have to integrate 1 upon 1 minus cos x upon sin x dot dx. So after taking LCM in denominator, The sin x will multiply with 1, will give us sin x minus cos x upon sin x. But as we know, denominator of the denominator will go in numerator. So here we get sin x upon sin x minus cos x. Now let's multiply and divide by 2. So we can split this 2 sin x as a sin x plus sin x and individual denominator. So we need to set differentiation of sin x minus cos x. We already have sin x. So let's add and remove cos x. So we will get two separate integrations. Let's say first one is your I1 and second one is your I2. So let's integrate one by one. First of all, let's try to integrate your I1. And for that, you have to assume sin x minus cos x as a new variable. So let's say sin x minus cos x is equal to t. Differentiate both the sides. Differentiation of sin x will be cos x minus differentiation of cos x will be minus sin x dot dx will give us dt. Or we can say cos x plus sin x dot dx is simply your dt. So we are ready to modify our integration. This sin x plus cos x dot dx will become dt and 1 upon sin x minus cos x will be t. So we can say integration of 1 upon t is simply log mod t plus c1. So to get the final answer, just substitute the value of t, which is sin x minus cos x. So here we get our I1. Now it's time to integrate our I2. But in I2, sin x minus cos x, sin x minus cos x will cancel out and we just have to integrate 1. So we will get x plus c2. So here we can say our final answer I is 1 by 2 of I1 plus I2. So just place the value of I1 plus value of I2 plus C, where C is C1 plus C2. Ta-da! This is your final answer. Here we have to integrate sin cube x plus cos cube x upon sin square x into cos square x. So for simplification, let's take individual denominator. So in first term, sin square will cancel out. We will get sin x upon cos square x plus in second term, cos square x will cancel out. We will get cos x upon sin square x. In further simplification, we can say this cos square x is split into cos x into cos x. So this sin x by cos x will become tan x and remaining 1 upon cos x will become sec x plus. Similarly, in second term, we have to split sin x into sin x into sin x. This cos x upon sin x as a cot x and remaining 1 upon sin x will become cosec x. So we are ready to integrate. Integration of tan x into sec x will be sec x plus integration of cot x into cosec x will be minus cosec x plus c, or we can say sec x minus cosec x is your final answer. Ta-da! Here we have to integrate sin square x minus cos square x upon sin square x into cos square x. For simplification, let's give individual denominator. So in first term, your sine square x will cancel out. We will get 1 upon cos square x minus in second term, your cos square x will cancel out. We will get 1 upon sine square x. So here we just have to integrate 1 upon cos square x, or we can say sec square x minus 1 upon sine square x, or we can say cos x square x. So integration of sec square x is tan x minus integration of cos square x is minus cot x, or we can say plus cot x plus c is your final answer. Ta-da! Here we have to integrate 1 upon sine square x into cos square x. Here we have to split the numerator, and we have sine square x cos square x, which is special trigonometry pair, in which we have sine square x plus cos square x as a 1. Now we can give individual denominator. So in first term, your sine square x will cancel out, and we will get 1 upon cos square x plus in second term, cos square x will cancel out. We will get 1 upon sine square x, or we can say we have to integrate 1 upon cos square x, which will become sec square x plus 1 upon sine square x, which is cos x square x. So integration of sec square x is simply tan x plus integration of cos x square x will be minus cot x plus c is your final answer, which is given in option B. Ta-da! Here you have to integrate 1 upon sin x into cos square x, which have special trigonometric pair. So we can replace this one by sin square x plus cos square x and give individual denominator of sin x into cos square x. So we can simplify this as sin x cancel out, sin x upon cos square x, which can be converted into tan x into sec x plus in second term cos square x will cancel out 1 upon sin x, or we can say cosec x. So we are ready to integrate. Integration of tan x into sec x will be sec x plus, and to integrate cosec x, we can say log mod cosec x minus cot x plus c. Here we have our final answer. Ta-da!